Okay, so we're gonna start a new unit, unit 5, and it's gonna be about three-dimensional stuff, all right? We've been basically living in two-dimensional world of triangles and squares and stuff like that. Let's go ahead and open this link up. Okay. So what we're gonna start off is we're gonna take a shape. We're gonna start off basic. We got a rectangle here in a coordinate plane. Pretty cool, it moves around. All right, what happens if you rotate a rectangle around the x-axis? Now notice how, if you look at the x-axis, that's red, the rectangle's touching it. But right now we're just gonna be spinning things around. And as you can see, as we rotate around, I'll kind of stop right there. Maybe I'll go from more of this angle. All right, and I can go back around. We start spinning this rectangle around the x-axis, and it creates a cylinder. All right, so one way to think about a cylinder is just a rectangle spun around, all right, rotated around. All right, now let's go around the y-axis. And it's not always the case, but sometimes you get the same shape. All right, we start rotating around the y-axis, and this rectangle would form a cylinder. All right, pretty fun and satisfying. All right, now let's go to a different shape. We're gonna go to a triangle. Oops, accidentally ruined it. We'll start with the x-axis. And again, you start to spin it. Let's get this view. This is not a bad view of the triangle. Oops, right here. You start spinning it. Actually, not the best view now that I think about it, because it kind of looks like some kind of circlish thing. You look over here, actually a cone. All right, so a cone, if you think about spinning a triangle around an axis of rotation, you get a cone. Pretty cool looking. From some perspectives, those looks like a circle. From some perspectives, it looks like a triangle, but is in fact a cone. That'd be a good circle view. All right, and we're gonna spend a lot of time talking about each individual one of these shapes. And if we go to the y-axis, similar stuff happen on. We get another cone-like figure. Actually, exactly a cone. I don't know why I said cone-like figure. All right, pretty cool stuff. And then this might be my favorite one because it gives us two different shapes. All right, if we go around the y-axis, if you take a semicircle and spin it around the y-axis, how it's oriented like this, you get one of my favorite shapes, which is a sphere. I think sphere might be top 2 shape. That's just a semicircle. This one though, I appreciate the difference because notice how it does, the way the semisphere is oriented and touches the green y-axis, it's not really oriented the same way with the red axis. All right. This, I believe, is kind of called a torus. I gotta double check my facts there. Half a torus. But you got this semicircle, kind of making like a bagel looking thing. There's kind of like a tornado in the middle, vortex. All right. Some reason this reminds me of Star Wars. But that's what you get when you rotate a semisphere. All right. So it's fun to talk about this, but I definitely wanted to visit GeoGebra so we could see this stuff move in real time because I think it makes it a little bit more meaningful. Okay, so now we're just gonna go back into more of a note type format, but axis of rotation, all right? It's imaginary line in which a shape rotates around. All right, so it's just a line. All right, we already talked about it, I showed it to you, but now we're just being a little bit more note formats. But if you take this triangle right here, rotate it around that red line, all right, you're gonna get a cone. All right, this is how we draw a cone. All right, what I like about this, sometimes it's fun to be on the line. This time we're off of the line. So what happens if you take a circle? Well, you rotate it around it. And again, gotta fact check my work or my knowledge. I'm pretty sure this is called a torus or a donut. All right, over here, again, I like the differences. We don't have to be basic. This is kind of like a circle, but there's a gap missing. So yeah, like on the exterior, you rotate it really fast, you're gonna get a sphere. But if you crossed it in half, all right, it would be a hollow sphere, all right? So this is kind of like a basketball or something like that, all right? And then, again, we're gonna be repping these words a lot. I know you know a lot of these words, but a rotate a triangle to get a cone, rotate a rectangle to get a cylinder, rotate a circle to get a sphere, rotate a trapezoid to get a fruchtdome. All right, that's a hard word for me to say, fruchtdome, all right? But what we're just trying to build up is, yes, there's a connection between these two-dimensional shapes to these three-dimensional shapes, but there's going to be a lot of differences, all right? We're just trying to connect it to prior knowledge, all right? And what we're going to do right here is we're going to take these shapes and we're just going to draw what the cross-section might look like. So like for this vase, we're just going to try our best, all right? But if I had something like this, all right, that would be that shape. And then if I rotated around this axis really fast, I would get this vase right here. All right, I took ceramics back in high school. I liked it a lot. And that was just a bunch of rotations, so that kind of makes sense. All right, this barbell right here looks very light. I'm sure I could lift this very easy. All right, it would look something like this. All right, I'm trying to do my best to draw the individual plates. All right, I'm a very good artist. All right, if you spun what I just drew around this line right here, if you spun it really fast, boom, you would create this dumbbell. We have this wedding cake. Let me see, I'll try to do like the whole picture kind of thing. I'm just trying to do like more of the silhouette too at the same time. So not the whole picture, but something like that, all right? Wow, I'm really good at this. You guys are probably impressed at my drawings I'm doing. And here's the torus, all right? Let me think about this one right here. We're gonna do a kind of like a ball. Actually, where would I want to put this ball? If I put it right here and rotated it around, let's actually kind of draw this more. I don't think I've ever tried to draw a torus in my life, but that would be it. All right, here's my little sphere, rotating in that direction to create the torus. All right, maybe I need to practice drawing bagels. All right, I'm so skilled at a lot of things drawing, that's not one of them. Okay, so here, now we're gonna practice just taking these shapes and drawing the shapes I already talked about. So we have this triangle, we're gonna rotate it around this shape. All right, let me think about how I wanna do this. All right, I can do it like that. And then you kind of have this circular. Guys, I'm not gonna lie, I thought I'd be better at drawing these shapes. I'm a little bit embarrassed by my skills right now. That's the circular base of my cone. Maybe if I made it all one color, it'd look better. All right. Maybe. All right, but that's a cone. All right, you're gonna have a circular base because you're spinning it. All right, but then it's gonna converge at the apex, and that's the cone. All right, I know I can draw a sphere okay. Hopefully. I think if I could freestyle these shapes, I'm fine. But when I'm given half of it, some reason I'm struggling. All right, that's a sphere. All right, and this is supposed to be a, so you know, this is like the circle showing depth. All right, so it's kind of a circle. Think about looking like a plane. That's why it's oriented that way, but that's that. All right, and then this last one, you got the rectangle, put it over there, getting better at it. All right, that's my cylinder. All right, so cone, sphere, cylinder. All right, so we're gonna do the same things now. We're just gonna take these rectangles, all right, and what I like is how I have them in a coordinate plane, but they're oriented differently within the axis. All right, so we're gonna take this here, and just, what if I put this shape right here? All right, giving myself a little bit more room to draw. Okay, here we go. I'm starting to get better at drawing these shapes. Okay, so if I rotated that rectangle around the axis oriented that way, I would create a nice little cylinder. All right. Now, what I like about this next one, it's the same exact thing, but it's shifted 1 unit to the right. All right, so let's see. I'm gonna do the pre-work and put it on the other side, what it would look like. And then kind of do this, where it's gonna be a cylinder with a gap in it. All right, so it's almost like a toilet paper roll. Unfortunately, that's the first thing I thought about, but this one would be more of like a toilet paper roll. All right, it's a cylinder, but it's hollowed out in the middle. All right, and then we're gonna have the same thing going on here. We're just gonna go a different direction. All right, we'll put it right here. Then we're gonna rotate it over the x-axis right now. So again, I'm gonna do my pre-work. It's gonna be the same exact thing, just a little different. Oh boy. All right, again, that's just a hollowed out cylinder. I'm gonna give myself a compliment and say I'm doing a good job. All right, just 2 more problems to rep it out. This is a state test problem. We got JKLM. All right, which 3-dimensional figure could you resolve from rotating the square JKLM 360 degrees around the y-axis? All right, so something that we gotta understand, all right, technically I could, just by looking at this picture, after rotation, no sharp corners. All right, I could write 90-degree angles, sharp corners. I just wrote sharp corners, but there's not even really going to be any type of angles. All right, however you want to phrase it. So like anything that has angles, that has angles, that has angles, everything's going to be smooth. All right, so just by looking at the picture, I should know it's this one right here. And here's kind of the toilet paper roll I was talking about. Unfortunately, talking about toilet paper rolls way more than I wanted to. All right, but it would be this one right here. All right, you can kind of see rotating like that, that's the shape we would get. All right, that's a state test problem. And here is just asking to draw the axis of rotation that would produce the telescope in the image. All right, so it's going to be at a slight angle, and again, just do our best. Kind of gets bigger and bigger and bigger, and then it ends. All right, but if I took this figure, rotated it around, I should have made the color different, rotated around this axis, it would produce that telescope, and that's that.